Good morning to all. This session is in continuation with the previous session where we started various kinds of systems in signaling systems. There we began with causal and non-causal systems, static and dynamic systems. This session is also the continuation of those two topics. Now here in this session I am going to clarify and distinguish between these two different types of systems in full-fledged clarity. Let us start. Let us start. Now, we already started systems. Now, in these systems, we are going to discuss, already discussion started. This is an extension of the previous class discussions. They're here, just static and dynamic systems. And we also discussed another system that is called causal and non-causal systems. Causal and non-causal systems. Generally, most of the students get confusion in making the difference between these two different concepts. That's why in this class, just I am writing these two different kinds of systems at a single place. Now, it will be very easy for students to understand how to differentiate between these two different topics. Let us start. Again, one more point. Wherever and whenever we are going to start or we are going to discuss the topic of static system or dynamic system, which word is dominating? Memory is dominating. Memory, the word memory is dominating here. Now, memory means what? If a system is having memory, that is called dynamic. If the system doesn't have memory, we call it as static. So, static system is with the non-memory, dynamic system is with the memory. Now, come this one. Regarding causal and non-causal system, here one word is dominating. That word is called future response or future response. It is based upon this word only. Students have to differentiate between these two. This is an easy way to get remembered, to get understood these two concepts in a full clear-fledged way. Just look at. Again, I am repeating the same important concept. Whenever we are discussing static and dynamic system, students have to concentrate on the word memory. Memory less system, memory system. Here, causal, non-causal system. If a system takes future response into consideration, that is called non-causal. If a system doesn't depend upon future, that is called causal. That means what? Causal system doesn't depend upon future response. Non-causal system depends upon future response. This is very important. Come this side. A system which doesn't have memory, that is called static. A system that have memory, that is called dynamic. Very, very distinction between these two things. Students have to remember and understand. Now just look at, we are going for the mathematical representations, and as a student, how you can differentiate between these two. In examinations or analysis, generally just look at, a mathematical equation is given. For example, y of t equal to x of t plus x of t minus 3. Look at, a mathematical modeling is given. Now, how they will ask you? They will ask you that verify whether this mathematical modeling of the signal belongs to static or dynamic. This question they will ask you like that. Now, just here we have to verify whether it belongs to static system or dynamic. Verify. How you can prove it as a student, how you can prove it. Now just look at For example, put t equal to 0 or 1 also, t equal to 0. T stands for time, at present time, t equal to 0. Or you can make it instead of 0, you can make it 1 also, choice is yours. Okay? For example, t equal to 0. Then substitute the same value of t in the given mathematical equation. Wherever t present, we are supposed to substitute there only. So here this is y of 0, that is equal to x of 0 plus x of, put t equal to 0, then what happens? Minus 3. Now x of 0 represents what? The present response. Represents what? The present response. Here x minus 3 represents what? The previous response, past response. Past response means what? It has to get memory. What were the outputs of in the previous case? The system should have memory. What were the inputs of the previous system, previous cases? If memory is not there, the system cannot remember all these things. That means these are previous systems, previous responses. Now you can ask me one more question. What do you mean by previous response? Now just look at, you can make a scale like this. In this scale, this is 0, this is 1, 2, 3, like that. Here minus 1, minus 2, minus 3, like that. From 0, if you go towards future, if you go towards left, past, previous cases. 0 is present. Present value. This is present value, this is future values, these are previous values. Students have to make it the distinction between these three. Now this is previous. Now just student has to write that. What a student has to write? Here the system not only based upon the present response, but also depends upon the previous responses too. That's why the system is called dynamic system. The system is called dynamic. So dynamic system means what? A system not only responses to the present one, but also responses to the previous responses also. That is called dynamic system. So dynamic means what? Present and previous responses. Now just look at, you can make it another example. For example, y of t is equal to, this is second example, y of t equal to 3 times x of t, for example, x of t. Verify whether the given system is static or dynamic. Then put, what do you put? Put t equal to 0. Then what happens? Y of 0 is equal to 3 times x of 0. Now just look at here. X of 0 is the present response. X of 0 only gives the present response, but it can't give, there is no previous responses. There were no previous responses. There were no previous responses. No previous responses means what? The system is only static only. It always able to respond to the present input only. It can't get any response to the previous inputs only. That's why this system is called static. So this system is called static system. Students have to get a clear-cut distinction between these two. Very much important. Static system. So this is, whenever you discuss static and dynamic, memory less. This is memory less. So it is not able to not capable of keeping the previous inputs. This is static system. This is dynamic system. Now just look at. Now come this side. How to remember casual or non-casual? Now just look at, you can take y of t is equal to x of t plus x of t plus 1. Now just look at, put t equal to 0. Now this becomes y of 0 equal to x of 0 plus x of 1. Now just look at, this x of 0 gives the present response. The present response. Here x of 1 is called what? Future response. Future response. Therefore, the system not only depends upon the present response, but also depends upon the future response. Future means what? In the scale we are moving towards right side. So this system is called non-casual system. Non-casual system. This is non-casual system. Now just, you can make it another one. That means what? y of t is equal to x of t plus x of t minus 3. Now just look at here, verify whether system is casual or non-casual. That means what? Put t equal to 0. In this case, y of t, in this case, y of t gives what? X of 0 plus x of minus 3. Here there is no future inputs. No future inputs. This system is called casual. This system is called a casual system. So one important point is that students may get the difference, some confusion between example under this heading and the same example under this heading. How to get it? How to get the clarity between these two? Look at static and dynamic systems always are having with negative sign. Look at negative sign, negative sign. Casual and non-casual system differentiation are always with what? Positive sign. Look at t plus 1 or t plus 2 or t plus 7 or it may be all with positive response. Now the same problem can be discussed under casual, non-casual too, because casual, non-casual means what? Student should not make this into consideration. Student have to concentrate on the point that does it have any future response or not, only future response or not. Here just look at x minus 3 is past response, not future. Therefore definitely under this heading this is casual. Here just look at t plus 1. T plus 1 means what? It depends upon future response. It depends upon future response. Future positive. Plus 1 means what? Positive. Wherever there is positive sign, definitely this concept comes under casual or non-casual. This is t minus 3. Whenever there is negative sign, definitely comes under static or dynamic system. There is one special cases like that here. The question seems to be belonging. It seems to belong to this concept. But what they asked under casual or non-casual. Students have to very much clear about this question. This question, because of having negative sign, students generally think what? What do they think? Static or dynamic? Because they contain only negative. But what question they asked? They asked whether this system comes under casual or non-casual. So whether casual or non-casual means this is present, this is past, but does it contain any future response or not? Because what they asked for casual, non-casual. So students have to concentrate only on the future response, not on the previous response. So according to the question, the output is no future inputs. Therefore here it is casual. The same system is asked. The question is different, system is same, static or dynamic. Here we ask it contains negative. Negative means what? Definitely dynamic. The same question, but title is different, same model is same, equation model is same, title is different. They ask for casual, non-casual. Here it is casual. Doesn't contain future. It contains here, if the same equation which comes this side, it comes under dynamic. The same equation comes that side, that becomes casual. This is the main difference between static and dynamic means most of the cases negative. Casual, non-casual means most of the cases positive. But here, sometimes this to be understood. Thank you.